Hello and welcome to another video. So we've been looking at, I'll bring this in. We've been looking at this build your own BitTorrent challenge as part of the Codecrafters challenges, which as you can see there are quite a few and you can do it in a bunch of languages. Not a sales pitch for them, but I do rate them, but yeah, you do have to be a member to get dark mode, but it's also pretty cheap, depending on things. So I kind of stopped at the end of the last one, which was pretty much we can download. There's some limitations. You can download any torrent with an HTTP tracker, no HTTPS, and also can only have one file. But that's just what it is. So there were a couple of things in there that I didn't quite like when I finished it. One was the HTTPS, which I thought, I don't know, maybe I could go about doing it. So I actually started looking at this old standard here. Where am I? 4.6. The Transports Layer Security TLS protocol version 1.2 and 4.6, somewhere there. So I started looking at this. It kind of screws up when you do that. To I don't know, look at implementing TLS from scratch, which could be quite a cool thing. I won't be doing it in this video, so if you come for that, you've come to the wrong place. But I have made some starts on this magnet stuff. So, as you know, if you use BitTorrents, you sometimes just have like a link with magnet, colon blah, and that will kind of work out everything about it. So what we can see here, I might bring this over here, and in fact, like, is this big enough? I don't know, that looks kind of funny all over. If anyone from Codecrafters is watching, it would be cool if a triple click on your, like, I assume this is a it's a code, but potentially if it's a pre instead of a code, it will not select the line above, because a double click will only select the word wherever you want to do, but a triple click will do the whole line. But in some places it would be handy if you could just be able to like copy things. I don't know, pet peeve. So what this first stage is very similar to the first stage of like the BitTorrent one, when we're just decoding stuff. So here we are basically given a URL which is of magnet schema, and in it we have xt parameter and dn and tr. And some of these are optional, so dn is actually optional and tr is also optional, but if tr is not there, then you have to do the distributed hash tables, which is a something that they suggested that would be part of this. I can't recall how to see that though. Yeah, like once I finish this, choose extensions. So DHT is one, so maybe I am interested in that because I have seen it up in some of the tests. I'm actually secretly interested in all of these options. Multi-file. I was chatting with my friend and I told him like all my challenges of single file, and he's like, why can't you do multi-file? And I think like the multi-file shouldn't actually be that much harder. Some of this I could kind of just do off the thing, but that is that. So there are a few things I have done in this, which I will kind of talk through, because I kind of just did it, and sometimes it's easier doing rather than kind of doing it. So I had to make change. Well, no, that's not a change. That is just me being like, I wonder what I can do. So yes, I've included a URL query. So this is something new. So in fact, can we open you up? Yeah. This is a kind of new header only library. Can we do that and that? Yeah, maybe that's what I want. The new header only library, which I have not really made into a header only library. I've kind of just shoved a C code straight in. So if this is included in multiple places, then it will not compile. There will be too many references. It's just how it is. But pretty much what I've done here is I've kind of done like I don't know, playground of some sorts, because like byte buffer probably doesn't need to be there. Probably doesn't need to be called byte buffer. It could just be a generic buffer of a something, because here we can see that we don't really need to know that these are the things. We can actually just append quite easy and reset reasonably easy for anything, and we can see that I actually this kind of does yeah, I think that, yeah, so here I just do +1, but down here I do plus size of p, which I could probably just make this up here and then change that to be a buffer. Anyway, I digress. This has basically a bunch of structures to try and make a thing which kind of made sense at the time. Basically, you have once you get a URL, you can parse the query out of it, and if it succeeds, then this URL query parameters will have some data in it. Hopefully, it may have none. And what that data will be pointers. Well, it will be an array of pointers to URL query parameter, and I chose it to be pointers just so there's less values being copied around, because these are starting to be a bit larger things. Like each of, like these two should potentially be pointers as well, but yeah. And I don't know, that has a URL query parameter, and that has a name and a value, or a name and data, and that's why that's a pointer, because that is an array of byte buffers, and a byte buffer will be able to construe what the value is. And the reason for that is because in the spec, for URL parameters, you can actually have multiple parameters. This is over and above what you need to do for the magnet links, which you can have multiple things, but I don't know. I didn't really need to do this, but I don't know, I kind of had fun, and I'll probably maybe migrate it into the URL, or have it as a separate one, potentially as a separate one, and that's kind of what it does. So if we go here, so that's already staged. I'll go through what the other changes are that there are. So needed to get some stuff, did some stuff. I'll potentially just add it all in and clean it up later in other commits, because it's got this magnet pass, which is really what we need. So this will parse the URL, and interestingly, we need a scheme of magnets, and our URL library, if you had been following along, only actually supports HTTP as a scheme, so had to do some changes in that library. Haven't published yet though. But what they'll do is it'll go get stuff, and then once we parse the URL query, we can then kind of get like all these things, and like that could probably be something shorter. But we can get our parameters for xt and tr, and xt is required. Xt, you can have multiple, I think. No, xt was one, but tr you could have multiple. Yeah, I think that was the way around. And so with that, we just do some checks, and xt we make sure kind of starts with the right thing. I mean, potentially we could shove the whole value of xt into another URL pass, but that seems kind of overkill for what it is. But then we can kind of work out what it is, so what hash type it is. So the BTMH is version 2 of this spec, which is linked from that page, BP9. So it's basically talking about the peer-to-peer communication for magnet links. So we do that, then we get the hash, we make sure that it kind of looks right, well, has the right length at least. We don't actually check whether it has the right, like they're all hex characters. We probably should, but yes, and then here we kind of support multiple trackers by saying don't support it, but that's alright. Otherwise we print the tracker URL, because that's all we wanted. So we do that, and then we get the info hash, and we just print out the hash, and that's just verbatim of what was put there. They use a different one here. It's kind of a bit confusing that they provide like this magnet link with the AD, and then they want the info hash of D6. Interesting. But if I am correct, there were some other files. So pieces, that was all that. URL. So URL had to do some changes. This will necessitate a new version of URL to be published, and I'm quite happy to do that. The first thing I do is remove the limitation to only HTTP, and I kind of put it in this because you can have two different types of URLs. You can have the kind of schema, then something straight after, like this is. So that's the schema part. Then there's no authority part, as they call it. I didn't really want to right click and click. Which would be the :// part. So we kind of put that check in there, and that means we are kind of allowed to have any scheme that isn't in this part. That with this we are still limited to HTTP and HTTPS for the URL parsing, not for the URL connecting. But because of that, we can put the HTTP here. And the reason for that is because I wanted to show info about torrents that have that other trackers, but I can't talk to them yet because, yeah. But yeah, that's reasonably straightforward, and this one I probably won't commit because it will not like things. So what I think I need to do is go into URL, and this is like it's going to necessitate a new version of things, and so I should really put like the reasoning of why things there. What I can do is send the bring this over here, maybe scroll up and maybe like that. So I'm making a change. It's not an incompatible change, so the major version should stay the same. The minor version, I'm adding new functionality. I am adding functionality to allow authority list URLs as part of it, and I actually did some patch work as part of that. But because of that, I think I want to go like this and not that. So it just brings the version up. And then I don't want to do that. I'll just do that. Do this. Do that. Pieces. That isn't that. Now URL. I should also probably do that. Do that. Do that. And I should probably make that URL part of the other library. But I guess what I can do here is stage 1 of what was it? Magnet parsing. Magnet parsing. So what can I do? I can weird. Why did it mentions the background? So what I can do is maybe cd dot slash. Oh no, I can just go cd url.h. And what status do we have here? We have actually modified it, which is concerning, because what have we done? We've just added that HTTPS. That was when I was trying to test things. So I'm quite happy copying from source, personal published, and what project are we on at the moment? It's a Codecrafters. Is that in? Yeah, that's in there. And we want to copy url.h to here. And then we should do ECC example.c and a.out gives a seg file. Now why is that? It is because we are expecting just a single URL, which we will then connect to. Gosh. The example is probably not the best, but that probably means we can go to http example.com and it gets somewhere. But I am also wondering whether it will kind of do this and be alright with this. And I wonder, was there any quotes in there? I think I do need to just do that. So here we can, it gets to the point where it's trying to look up the host name of null, which I'm happy with that. So we did a thing. So version 1.1.0, and what are we adding in this? We add support for parsing HTTPS schema, and also any schema without an authority part. Yeah, that's probably what I want. No support for HTTPS connections available. That is probably what I want to do. Nice and small, so we can probably push that up, and then we can probably push this up. That pushes to there. We can probably also push this to GitHub, and then this we can probably, I kind of want to just stash that. Is that like, no. How do we do this? Do this and stash CSZZ, cool. But we could stage everything that we want to stash and do that CZS. So what do we want here? We maybe stage that and stage that, and like CZS. I didn't like it. That's because like I got a newer CZZ. Boom. I'll just get rid of all of it. Cool. So now that that is done and my tests have passed, I will mark this as complete and we'll go on to the next stage. And that's what I want to work on in this video. Having no idea how long it is, hopefully I will get it done. So what is this? Right, our client supports extensions, cool. Right, so that's just part of the extension. So what do we need to say? That is way too white for me. This kind of says it anyway. So we already have like extensions, well, kind of. Let me find where the extension, this probably shows me. Cool, so you can close things. And is this where we are? Yeah, so in pairs, these are reserve bytes, sorry. Well, they're reserve bits that say a certain extension, and in fact, the server, the tracker that we're talking to actually has an extension, which was confusing when I was doing it. I was like, it's not sending all zeros, but I looked into it and I worked out which one it was, and it's one of these many tabs. But yeah, so what we have to do is we send our 8 bytes. So we want the 20th bit from the right. So I wonder if we can, because we send our extensions here. Extensions, and what I should probably do is actually make this like int8 extent extensions, and there are 8 of them, and they can just all equal 0 to start with. And then what we can do is len plus equal dprint f, and we can do sock, and we can not sock. I kind of want to do a write here. Is that like possible? But like a write, it doesn't guarantee that it all goes out. So I potentially do just want to go. Oh, I don't like it. I just want to write this entire thing. I think I do have to kind of just do a write to socket and extensions, and this will be the size of oh, well, is it a size of extensions? No, we just want to do this. And we kind of want to size t, and what's this? Oh, I've got a red val. And we kind of want this to be, so we can start off with that, and while ret val equals to this, and this is going to be 8 minus ret val. No, that's not what I want. Can we do something like that? No, I do kind of need to do size t extension. Oh no, we have a write full. Yeah, we have a write full extensions. Boom. Which that how do we get there? Over here somewhere? No. No, not that one. That one. That is the one we want. How do we get there? It's we have a rightful somewhere. Yeah, it's in common. Which is interesting that we use it here. In common dots c. In common dot c. No good for header only. Just do that. Cool, and then that does that. And so, how does this work? So, not that one. In this one. Cool. So, do we also need to define this in? Well, it'll tell me. But yeah, so what this does is it is saying that, right, to this socket, this data, this much of it, but it will do that kind of checking and like sending everything, which the dprintf method, you can't just say, like I can't just go right, because it might only write 1 byte or it might write 0 bytes. The dprintf is guaranteed that it will write it out just because they do the buffering. But in this particular state, so I want to go here, then here, and just do this, and fix me. Yeah, that one. And we can figure that out. So that seems to be working. What I might do is do this test previous, that one. And that will see whether I broke anything, because before I kind of get to like adding in the fact that we have our extension, I want to say that things still work. So things do not still work. So we go to 76. So sys exits and 76, what is that? That's a protocol. So that's just somewhere in there. So do we have a handshake? Yeah, we can do a handshake of that. So yeah, it's just crashed out there. And what if we do it? I had naively thought this would just work. We want len plus equal to this, and rightful doesn't actually do anything, so maybe I kind of want, just for my sake, because I know C is sometimes weird, the size of extensions, and we probably want to do this as a ZU, and do something more like that, size equals, and if we do this, and maybe we can do that, and do this, sure, no, what about if we do just that one? Cool. And then we can kind of see what happens. So the size is 8, and that is kind of what I want to know, because if we say change this to that, what would that tell me? That would tell me that it's 16. So the 8 is really just the size of this, not of this. So we kind of want to see what the size of that is, but then also the size of extensions 0, which is always like it's a weird thing. So here we have 8 and 1, so that means that, oh no, that kind of is right. So there's 16 bytes in that, but that's not the case. So what we need to do is do the there's like some weird thing that you need to do. It's kind of annoying that they're both there, but like size of, yeah, I think we just want like that, and that is going to be the size in bytes that it is meant to be. Wait, did that break something? Right, so the size is 8 there. If we say change this to 16, it should. So yeah, I guess, I don't know. There are 8 extensions, so maybe what I should be doing is having define num extensions. Extensions, and call that 8, and then call this num extensions, and then all is kind of able to be done like this, and here we can do, I'm kind of just guessing that this is the error that it was complaining about, the fact that we hadn't updated this length, and if the length is not what is expected, then we just go to error very silently, but now it works. Cool, so learned that. So now if we go back to this previous, see if we broke anything else. So ideally nothing more is broken. So looks like things are working. We're like sending and receiving stuff. We're at the point where not doing any handshaking. We're just downloading pieces, which nothing should really break in there. And we say like one reserved. So we say when they have a reserved bit, which, gosh, which one is it? Not encryption. This, no. I think it was fast. Yeah, official extensions. And we had magnet handshake. No, that's just a new one that's just been added, so that's alright. So our handshake, we say reserved 7 is set to 4. So pretty much it is this. Reserved 7, set to 4. But we want to do it in a different place. We want to say 20th bit from the right. It's kind of annoying. Doing such an arbitrary thing. So we want to basically set extensions, and this is going to be so yeah, 8 reserved bytes, 64, so cool. Just need to work out which byte that is. So I guess, actually I know how to do this. So it probably wants like a random gross macro. So I might write it as if it is a random gross macro. So maybe I can do a define of no, this should really be an enum or something. So we could probably have a type def enum, and it is going to have some extensions. And maybe I will put in just all of these official extensions. I mean, someone's gone to the effort of adding them. So there's only a few, but I feel like none of these say this. Right, so this is the one we want. 44, is that right? 44 does not sound right from 20th bit from the right. So 64 bits, 64 minus 20 would be 44. And was that the number I was just saying? 44. Yeah, cool. So, yeah, I think I just need to kind of make this BitTorrent extension. Wow, I kind of want to make it just a BitTorrent extension like this, and what's kind of annoying is it goes away from where I was. This one, because I want to say extension is, no, we need an S in there. Extension equal 44. I think we can do something like this. And we want to type def this as what is this being called? Not there. Then there. No, there. Reserved bytes. Oh, is this just cool? This is just the one I want right at the bottom. Yeah, I'm happy with right down the bottom. And this is reserved bits, so it's kind of called extension. So maybe BitTorrent extensions. We'll just call it something like that. So here we want to do some gross things. So what we want to do is we want to take maybe call this extension protocol because it kind of looks a bit naff. Protocol. So we can get this extension protocol. Can we not do this in C? I've gotten too used to other languages. Extension protocol, because I just want this. Why you don't allow me? Is it like this? Tell me what's wrong. You did want that. Protocol. So we don't like this because that kind of, does this mean that we kind of need to make this so other languages you can do, so I was working in, gosh, what was it, Odin, I think, and you could like have a structure which kind of separates out the bits into something. Maybe it wasn't Odin. So you basically have a uint one type, which would have kind of all the things that you need. But what I'm thinking is this actually needs to be a define. So this needs to be a define, takes that, doesn't have an equal, does that. So then when we get extension protocol, this is by far too big for one thing. So we need to make sure this is, take me back to where I was. We need to make sure this is less than the number of extensions. So I guess this means that we want like a mod of it. So if we do, and maybe if we do a little test. So if we do a 44 and we do a mod of 8, that gets us 4. And we were saying that this 44 was the 4th most significant bit in the 6 byte. So we actually want this to be a 5. So what if we do this? Then we get it. So we do kind of need to make sure that whatever the thing is, it's over. So where are we? We need a I mean, we could probably just do assert. In fact, is there a static assert? Yeah, there is. I forgot about that, and I probably should have been using it this entire time. So we want to make sure that extensions protocol is less than num extensions times 8, this size in a byte. Cool. And then if we do that, so we will get the 5th byte, and then we want to make sure, so this will get us the value. So from this value we want to then, or in I kind of want to just make this a macro now. Define what do we call it? Set extension. And this is going to take maybe our extensions, and it will probably also take actually no, we could probably just do this like in here. We should probably take the extension, and what this is going to do is it's going to get this thing, but instead of this, it's actually going to be taking that. And what are we ORing it with? We are ORing it with doing that same thing again, but doing the divide, except this we wanted not that. Come on, find the S and do that a few times, and do that. And we are going to OR it with that divide num extensions. And this whole thing can then get set back to extensions I don't know what's up with the autocomplete, get the extension and do the mod of the num extension. And I wonder, the compiler will most likely do it for me. Well, we could probably just do this. Where is my pipe? Is it? I've lost the keyboard. Right, we'll just do the old-fashioned pipe. Which one is the pipe on? It's there. So we can do a that equals. I'm in a wrong layout. Need to be here. Let's push U. So here we can probably just do that, and here, that's like that. Right, so we get that. That was going to be the divide, but this was going to be the that. And I reckon I'm just going to assume people know what they're doing. Well, actually, I can just do this in here. So one thing I should do is maybe do all of this. That should have a semicolon, and do this while 0. So that would mean that it will do it at least once. And then here we should probably check that this is less than the possibilities that we have. So maybe this can probably go up into here, and we could probably take in extensions, which would probably it's good health to do that, just to make sure we don't overflow. Right, so that looks good. Maybe this can also go up here, and maybe we can have that just down there. Cool, so once we get the extensions, we just want to do something like set extension, take the extensions, and we wanted what? The extension protocol, and like maybe a bit tiring. I feel like just being a bit nicer to the old folk around, and kind of having prefixes, so you know what's what. That's can also go there, and there. And I think that might just do the trick. So what happens if we do the pair? What I kind of want to see what our reserved bytes is. So we could probably do this. Extension. Cool, so if we do this, it doesn't like things because we need to do that. What happens here? We wanted that. Right, we don't, see, like, do I want to, I mean, this is doing like a different thing altogether, but yeah, so we're in here, we want to include assert.h, that's what you want from me, except this should probably be down here, I don't know, but this is just how I'm doing things. So extension is unknown extensions. So this reserve size, which I put up here, is just the same as extensions. duplicate this current keyboard layout for that. And I kind of want to do that. But I also kind of don't want to. But what do you complain about now? So this reserve size is now actually extension size. And you just don't know about this. And that was also extension size. That was the same. That was the same. Cool, so now it says my extension was 4. So maybe I'll change these no, we need to go back to where we were and then search for worn. Sending extension that I don't know. Maybe I just want something like this and receive something like that. Cool, and then it will say that I'm sending it and also receiving it. Cool. So now what I want to do is, did I close that window? Interesting. So I guess I want to go into this and then Codecrafters test and previous, and just make sure I haven't broken anything. If I have, I shall fix it. But I have a feeling I haven't. Right, here we are. Interesting. So this. Yeah, we're setting the wrong thing there. So we're setting 5 and 04. 5 should be 010. Wonder how the math kind of gets sorted there. So I pushed too many buttons. I'm still pushing too many buttons. Control Shift is that. Bring up. I just need to go there. Cool. So this is the one we want. That doesn't really say which number it is. Does it say? I love it. Extension profile. Cool. So you got this extension thing. It doesn't really tell people anything. misunderstanding this. No, we were all 0. So 20th bit from the right. And the right is that aside. So that should be 64 minus 20. And 64 minus 20. Well, I mean, we can do something like that. And it is indeed 44. So 44 divided by 8, that was getting us the chunk that we're in. So we're dividing each of the bytes up into that. So it's in the 5th byte. And I thought that it would be something like this, but it is actually, I think, 8 minus 44 dash that. And I think that's what it is. So if we do that, then I mean, that's just the same answer, isn't it? So this had 44. 4th most significant bit in the 6th reserved byte. I don't get it. No, I'm not doing a thing right. So what I want to do is, come on, get up here. So in here, let's maybe do something like that. So we get the right bit, and then we get the right, this is needing to go from the edge all the way to there, all the way up to however many things. So I think it might be this, and if we do that, I lost what I had. So now we're seeing extension is 1, whereas before we were seeing 5, and I think that is right. Helps if you actually shift the bit along, not just do some naive, like, yeah, this will work. Cool, so if that is all the case, has to get all the way down to the end. We also need to implement a new handshake command. So we're sending the handshakes. It still seems to be working in all the last stuff. So I think this is potentially a point that we should add all of the stuff that we were just doing. So that's that, and what's this? This is also changing that. Cool. So maybe we can do that and start sending extension protocol. What do I want to say? Support. We now support this. That is kind of what I want to do. Now, what I kind of want to do now is, so we have a magnet handshake. So if we do something like this and magnet, do I want this one? Yeah, this is the one I want. So this is just parsing it. But if we do the same, but instead of that we do handshake, this is now going to be my main command, and I think this can go now. So it'll drop me to the point that I wanted, and that's something that I worked on last time, I believe, that I put this error out, which will allow me to kind of put the file name and line number, so I know where it is. But yeah, what we need to do now is do this and handshake, and maybe find that and do that. And so that kind of means that we will need to do so we'll need to parse to get it. We'll need to do that. We'll need to get a pair. So this is getting to the nuts and bolts of it. Nah, I don't know. So what if we go here? Find that and replace that with what are we doing? Handshake. So what is the handshake? How many things were we parsing in? It was just like the one link. So we should expect that there is a thing. So I wonder if we should do this, that, this, that. I wonder if we just kind of copy paste all we have up there. Because what does handshake do? Handshake just does handshake file. So I wonder if I want to now do and what does this do? This does it decodes, so it gets everything, and then it does a handshake. So handshake pair, once I get the pairs, I can just kind of do it, which we don't parse. So easy. I think what I potentially want to do is it's kind of like a mixture of this. I hate like copy pasting stuff, but we kind of need to get the URL from that. So we do stuff there. All right. We need to do the tracker request to get the pair, and is that what random pair will do for me based on can we not get to random pair? I feel like I haven't run this in a while, or like cool, worked out where I was. So yeah, this does the tracker response, and we have to have a dictionary and a info hash, which I feel like we might not have. This tracker response, I guess, yeah, take me to this. It gets out the announce URL, so I guess this needs to have another layer abstraction. So what do I need from the dict after I parse the URL? Nothing. It's only after we kind of do this. So maybe this should be tracker response from dict, and it will do, well, actually I wanted to, I kind of want a tracker response, and it is going to take a URL, just a URL, URL, and we're going to give it the response as well. And yeah, so I think what I want to do is actually like kind of come here, and then at the end here I have this just from dictionary, and then once we parse the URL we can then just return, oh no, we can't just return it, we need to go ret equals tracker response, tracker response from just URL. So maybe here we will pass in the URL from URL. I think I'll just kind of prefix that. And what sort of thing? We also need to pass in the info hash and the response. Info hash and the response. And what happens if this, so I guess what I can do is just see whether we kind of from the URL maybe do something like this. Right, so this should probably be an int, and this length, we don't know length. So where was length coming from? Length was coming from this length. So we needed to know the length. And are we getting this? We're not getting this from the... We don't get this from the magnet information. We just get the info hash, which... I don't know. Maybe this one. Yeah, so we don't have the length. I wonder if we should pass that in, but I also don't know. That's just complaining about that. Is that what I want? I think it is, because we're kind of doing things there. Length, that's cool. What is this doing? Nested functions. Oh, I don't like the sound of that. Where do we have the nested function? Do you tell me where? Apparently here, but like here we, this is, So we'll be including something from somewhere. So it can't get to the end there. Oh gosh, one of these. So does this, we do a return? Cool. Maybe this can shed some light. Maybe we'll do this. That closes off things. This is also legit. So we're doing it in, and it's the problem with heteroinate libraries is we're kind of just including this into the one big file, and you don't really know where it's coming from sometimes. So we don't take that. There should still be that is valid. Then we add a new one. Then we go do some things, and we don't jump in here. So where did we get to? I guess I kind of want to work out what the go-to end will kind of look like here. So info length. So I guess the dicts didn't have anything. So we could probably just return this. There's nothing to free up. Does par0 do it? No, add query string does it. But par0 does not. By design, I think I did it. So here we can probably just, instead of all these things, we can return ex data error, and then hopefully we can just do this, because we've already got the dict parsed, so that should work. So we still don't have this length. I need to think about maybe if I do this and do is it that? Yeah. Cool. So we still use an end. We can probably return ex data error there. argv we don't use anything. Cool. So I guess happy case. Why do we need this length? What is add query string doing? So the length is just the amount of stuff that we have got, and it should just be a size t. But then like the upload and download, we don't actually pass them. So I guess here we should probably pass in the size t uploaded, size t d downloaded, and size t length, and that will take away this sort of thing, uploaded, downloaded, thanks. But now it will complain that we don't pass in a 0, 0, then length dash size. So we will have to pass in those. Right, so we actually had some errors in tracker response. So I'm surprised that nothing actually kind of complained about that a bit more. A bit more, you know, like here, like why? I mean, it's in a header file, but it's getting included. Well, I think what my problem is it'll just be defined somewhere. Like this, yeah. From dict URL, and this will be the URL size t downloaded. Oh no, was that? We'll just copy paste that, and like was this? Please. Uploaded, downloaded, length. Uploaded, downloaded, length. Uploaded, downloaded, length. Uploaded, downloaded, length. So then we should be able to do uploaded, downloaded, length. Cool. So that should do that. We still have this. Yeah, now it's kind of giving some warnings. From dict. From dict. And so here the random pair potentially should get changed, because we do want to like we can parse the magnet, and that gets us the I mean, it's gross. We parse the magnet. That gets us the hash, and I mean, it has everything there that we actually kind of want, and maybe we want this as well. Then down here, then yeah. So I don't really like just kind of blanket copy pasting that, but it is what it is. So I guess at this point we have a tracker. So maybe we would have a URL, and this is going to be the tracker, and we maybe coming here then, if not parse URL, is that what we want? tr value dot data. If we can't parse the URL for some reason, we probably just want to go to end. Hits me in the back later, but that is what it is. Right, so at this point here, we should be able to, like, can we get a tracker response from URL, say, and we could probably pass in that URL. I kind of want to have that hash still there. In fact, I kind of want to open up that, and then we can have a look at what tracker has, and tracker a response from URL. So we take in the URL. So we need to get the hash into a better format, I guess. So this will be uint 8t, and it's going to be an info hash, and it's going to be a SHA-1 byte length. And so what we actually need to do is like, we got the maybe we'll do this, and chuck that there, and otherwise what we need to do is we need to parse this thing, so size t equals 0, and we are asserting that the right, so we set hash to be where it is. So we are asserting that the size is 40 in this elf branch. So we probably need IDX and make that less than 40, which is actually just the SHA-1 byte length, if I'm not mistaken. How do we find you out? We can open up app.sha1 and sha1 digest byte length. It is that. How helpful. 160 divided by 8 is 20. Yeah, so it is not what I want. It's like 2 times what I want. That is, so yeah, I don't really need that. So I think I want to do this more like that, just to say that yes, I am knowing that it is characters long. That's good. Do stuff like this. So what do I need to do now? For each character in the hash, so we should be able to get a hash IDX. Really, it will be 2 times IDX. Is going to be 1 digit, and then 2 times IDX plus 1 is going to be another nibble. So I guess I should, if not, is where are we going? Keyboard there. Is X digit. I think this is a legit thing that we can do, is X digit. So if it is X digit, it will be a hex digit, either up or lower. Now, if it is yeah, so I kind of want maybe another one of those, and then just go, if not this, or not is X digit, hash 2 times IDX plus 1. So if neither of those are that, and I kind of want to get rid of that just to make it a bit nicer. If either of these aren't the case, we probably want to fprint std error expected 40 char hex coded info hash found non-hex character at IDX. And what IDX are we at the moment? And this is just going to be IDX. Cool. And we should probably also go to end, if that is the case. If it is not the case, we do actually have 2 digits. So I think I actually want to do uint 8t. So it's kind of like 2 nibbles. So maybe we can well, actually, we can just do something like this. So info hash equals, well, info hash at idx, and this is going to be equal to hash at 2 times idx, and shift that over by 4, and then we want it all on the hash of 2 times idx. Where do we go? I hate just putting it. I push the arrow key, and my arrow keys are not what you would call straightforward. And I think I want to just make sure that we are actually there. And this is actually wrong. So this, I want to actually convert them into digits. So it would be like D1, 8, not 8, and D2. And here we will do the making of int 8 type T D1 D2, and we will assign them to some things. Really, we should probably do something like that, just so it's not uninitialized. You get into a strange behavior then. So what D1 is going to be, it really depends on whether this hash 2x. So I think I want to do uint 8 t c1, and this can be equal to hash of 2 times idx, and this, if we find that 1 and go up 1, and then find maybe that, find that, yeah, plus 1. And here we can change in this to be C1, and change in that that to be C2. That makes it a bit nicer, and like I probably will need to not typo that. Cool. So right, so if is digit of D1, then not that, find D and do it again, get that. Then we want to have D1 is actually C1 minus 0. So if it is 0, it will go down to 0. If it is 1, it will go down to 1. You're basically taking off the ASCII character that it is. If that is the case, then do that. Otherwise, we want to make it equal to 2 lower. We pushed a key on the keyboard. 2 lower, and we want to take that C1, and we want to subtract it from A, and that should get us the hex character. And then we want to do the same thing, except find the, we can probably just do this, and change 1s to 2s, and just do that everywhere but ask me. Easy. So that is the case, and then we should be able to just do that. Yeah, and I think I want to do a very quick test and make sure that D1 is it shouldn't be more than what can fit in one nibble, or D2 is greater than 0xf. This is a weird error, and it should probably be. Do we have an unreachable? We do have an unreachable. I wonder if that actually does what I think it should do. We don't actually have it, but this is kind of unreachable situation, which potentially good to have it. So there is like a. We just want to bail, if that is the case. So once we get that info hash, we have it, and then we want to get the tracker. Once we get the tracker, we can then go to the info response and we can ask it to say we have uploaded nothing, we've downloaded nothing. Don't know what the length is. I'm just going to put length here. We're also going to pass it the info hash that we just did, and we're going to give it a address to a response that we can grab. So if we do this, I kind of want this. So we will get a bin coded value, and it will be pointed to that value. So that's what we want, and then we will then have a response that it's our responsibility to get stuff from. So this is the only place we do it from in here, but where do we call you from? Grab response from dit, because we should probably use it somewhere in pairs. So this is pairs from file. So we do have a length there, but we also get it from here, and that's a random pair, and that is probably a good thing to do to set this to be null, just to avoid having that. And what this is going to do, so this is actually going to, well, we can actually just do no equals this, and if tracker ret not equal to ex of okay, then we want to set ret to be tracker ret, and we can just go to end. Cool. So what do we want to do after we get this response from the thing? And I actually wonder if we magnet pass. That's not what we want. Cool. Right. This, we actually just want to call it a char star, and we do not. Cool. So where is the end? I guess the char star string. I don't know. Yeah, something like this, and this is going to be char star, and this is going to be tr value.data. So that's going to be the start of our string. So I guess that's going to be track, and then track plus strlen of track, and we want to pass in our tracker. And it doesn't like something, that's because we still need one more of those. Cool. Length does not exist. What do we do with this length? At this stage we've just got a magnet link. We won't have downloaded anything. Well, we won't have downloaded anything, but we kind of we need to know what the length is. So we mention length somewhere here. Here. Cool. I don't know. I'll just see what happens. Ooh. Cool. We'll go back to here. Go to here. So if that is the case, we've done a thing. Cool. So that's kind of not in the place I would have thought. So maybe I want to do this, and I just want to see what the mag. I want to get. Yeah, I want to just get something like this, and like it did give a little magnet somewhere. Did it not? Oh, sweet! It just has like a bunch of magnet links. Perfect. I don't really want. That will do, because what I want to do now is actually do some debugging. So this will be magnet handshake, and give it the old handshake. So if we go into here, we probably want to do this and layout source, and we can just break main and we can step through to where we get to, because we should get here, and then that is right. So here we can go in here. So here, what do we have for a URL? We have something, and we pass the parameters. What do we have for tr? Is that what we want? P start tr. What do we have? So we should have a data which looks somewhat like a thing. Now I wonder if that size there could be something useful. But for now I will go through and it should. I kind of want to break on 478. Yep, cool. So then if we continue to there, we should have a info hash that looks somewhat reasonable. It could be nice to print it out again, but right, if we look at track looks like a thing. So if we do something like this, oh, I don't want strlen. Frame. Like I want to be in frame 1, and I probably just want to break on parse URL, and after all that set up, alright, we can probably go to here and we get to the place we want to be. Alright, we didn't even need to send the strlen. Let's close that off and find the comma and then change to the comma to null and just make that look a bit nicer. Right, so here I assume we actually kind of, so yeah, it's true. We have a magnet. Oh no, we're going to be parsing on another URL, which is this one. Right, so that looks fairly legit. It's still true. So if that is the case, we should have a tracker, p tracker, which should have our scheme. Looks good. Port should be 80. Yeah. Our host looks legit. I'm confused why this complaint, but it's in here. So if we go into here, what do we have? We have this URL. URL does not look right. Right, cool. So that is our issue. So here we don't want to track a response from URL. We want it from that URL. And maybe now if we do this, it's doing a query. It's done a query. So I think I want to do like a TCP flow. Is that what I want? And I think that is the big one that I can do. And if we did something like this, it should kind of send what it sent back. Yeah, so it has sent back some things. I kind of want to break on it. So where do we, I want to break on main.c at 493. I actually want to have some water. I'm just feeling a little bit of a headache coming on, which probably means it's too late. I think I've had enough today, but it's probably all the talking actually. Furrowing the brow. So if we do that, and probably do that, and maybe run this. Right, so now it's done that track response. So we should be alright, that's all good. So what does response show? Response should be something, and inside of it, it is a dictionary. Cool. And what's the data in this? Data. Nah, it's just like generic data. But we can call it a encoded dict star of that, and if we go back here and we look at that, can't use arrows on the command line when you're doing that, but you can do some control F. Oh, you can't even do that. I was doing the wrong thing. But that's right. So there we can see that. We can have that, and gosh, it just keeps on. This rabbit hole, we want to control A, and then like forward a bit, maybe back a bit, and I'll just get rid of that and do that twice. Cool, so now we have the so if we do something like value on this, yeah, so now that is starting to let us see some things. So we can have a key. What's our key? Is gosh, it's like not too much. It's just that, which seems kind of weird. This should be right. I feel it should be right. So what I want to do is maybe get this like random pair. Because when do we use the dict? We don't. And we do something like this, but I think we will just pass in the response. So it's going to be value, tracker response. It's a bit different name. Do we need the info hash after that? No, we don't, so may as well not do it. And the pair is what is going to end up in it. Cool, so after we get this, we probably just want to return random pair from dict. No, we just want a random pair, and it is going to take that response and also the pair. And the end. So the end we probably want to do in this from dict. So we probably don't want to do that. But if not, if we can't for some reason get this random pair, then we probably should just go to end. Yeah, maybe that's just all we need. And then the end will be the same here. And here we don't need that twice. And I just realized we don't actually need that last one. We can probably just do that. Because it'll go to the end anyway. No, that's not what I want. No, that's kind of what I want, but this seems bad. Because ret is a bool, which C will let me do it because bool is actually an int, and these aren't ints, but this should probably just be false. Which means that we could probably just go that, and yeah, which probably means the track response from dict probably doesn't need to return a a thing. I don't know. Code's getting a bit messy, but it is what it is. So if this is all the case, we can probably just do a return true here, and every time we do go to end, we could probably just do maybe do this and replace go to end with return not with a space, return false, and we can probably just ask me about it and something like that. And then we can probably do a random pair from something else. Random pair from response. I don't know. Random pair. Random pair. So we kind of want to make this from a response, and this was an encoded value and tracker response, and we did not need that, but we did need that. And then here we probably want to from dict something like that, and this is like something that I'm starting off, but I haven't actually published anywhere. So and maybe do can we do something like this and replace response with tracker response, but ask me first and don't do those first two that were like above the screen. Do that, do that, and I said do a lot. Cool, so now it is doing some things. Implicit thing, yes, that is a random pair from response, which it's kind of interesting because, oh no, yeah, I was thinking this function is like exactly what I want, but yeah, cool. So random pair from dict, so we can just make things all still work, and that is that, and gosh, another time. So now it should do it again, and here I don't know what's happening there. Maybe let's get rid of that, and here we can probably get a actually random pair. So how do we come on, let me just do it. So they will like do that. Is that like the only way we do it? No, we can't do like this. And of course, I had it all copied in my paste buffer. There's like ways to do it, but I did all that and did a thing. Right, so that means that random pair from a response, and so now we can take we can give it the response and get rid of that, and if not, maybe do a print F so we know what we're actually using. And so now it doesn't say anything. That's alright. I kind of want to see what the response looks like. Because, I mean, it should be doing it. So if we do this TCP flow again, we can do that, and I can just we do like a weird thing, but we can probably that's kind of annoying that it's grabbed all of that, but I can make do. So if I yank that, and then we I want to do a curl, in fact, to announce something like this, and I guess the cat test might be a thing. So maybe we can not that one. If we do that, no, I want to do that. Yeah, that's what I want. And here I want to probably do this and then find a space and then find a bunch more and do something like this and no, that one thing. And then there's a one to do without the GJ. So GJ. Cool, and then something like that. So now if we do this and announce, and is that right? So it sent us stuff, but we don't want that second that. So I think it's just not sending me the stuff I am expecting, which makes me wonder what it normally sends. So what I can do is maybe do that TCP flow and maybe just with the tracker, and there's a handshake. We'll do a handshake, which will necessitate a tracker request. And if we do this, so here if I look up and see what the response I got back was, so we can see in here we sent in this info hash. Everything is lowercase, so it's compared to this one. The info hash looks different, but then we get a PRID, import that, uploaded that. So that kind of had stuff, but the info hash maybe wasn't quite right. I don't know. But yeah, here we do the info hash. I note that it's doing lowercase hashing. And yeah, so the at lines up with the announce. I mean, it's hard to tell when it's doing weird encoding, but that kind of seems unusual. Yeah, like there's just no pairs. I wonder if I use a different magnet, whether that will give me a bit more magnet handshake. Let's do this and that, and that. Thanks. Not debugging, thanks. But can we go to here go to here, go to here, go to here, boom. So if we do this, gosh, it's taking a while to think. What's it doing? Ooh, I don't understand why it's taking ages more to do this. So like, what if we cool. That's not what I want here. So I want this, and I want to change in there, but I want to my problem is it's copying that new line character. Yeah, that could not find scheme in URL. That now unsure. Segfault, that's always a good one. Is that all the time case? That's an all the time case. Then this second one, get rid of all of that, thanks. Magnet 2. Yeah, so magnet 2 it's doing a thing where it's taking a long time. And I wonder whether that is, and then like, but this is magnet, so I had to do like double escaping just because of them things. So that was just on that. So find that and do it again, do it again, do it again. I think that's what I want. I still can't find it. I don't know. Yeah, and like this is, it's timing out on that. And what about this old boy? Can we go back? No, do that. And then it's segfaults. So two issues, got segfault and that. So segfault in the second one just doesn't work. So I guess if we figure out the segfault, it should get to a thing where, right, so pairs is nothing. Random pair from response. I think that's kind of the issue that I was getting in. Come on, let's go. We probably need to do that and do this. So I guess we need to. I think. I don't know why this magnet 2 one took so long. What I want to do is maybe do Codecrafters TCP flow, not that one. Come on, getting tired, late in the day. Something like this. And if we do that handshake, what happens there? It's hanging on the HTTP request. So we've seen that, but it's just not sending anything back. Which I wonder if this info hash, I just want to always kind of do things. Right, well, I think, I don't know, I've made a bit of headway. There's a bunch of stuff that is still not quite working. That's like really gross and long. Like kind of done a bunch of things. What's this up? Kind of touching everywhere. Yeah, like have to refactor to make it so you can bring in from a request or a dictionary. Interesting. I don't know. I think I'll just have to leave it there and try and debug later. I probably won't debug on screen, just because it's fresh on my mind, and I'll probably want to just try and work out what's happening. Like if I were to have a guess, I would imagine that the hash that it's sending is not getting escaped properly. And like with the hash already in this format, it's actually potentially easier to just do a % every 2 characters, because that's the format it needs. It is what it is. So I guess if that is, I mean, I can kind of craft my own from this. That one. Magnet 1 definitely worked. Cool. So in Magnet 1, what I want to do is actually find that and change that to be that. And was it already that? No. But now if we do that, we can probably get rid of that just so we don't get confused at a later point. And so if we do that, it's still sending not the right stuff. But what do we send it? That's annoying how it does that. It just doesn't look right, does it? Doesn't look right. So D's, like it should be something like D6 as the first byte, I guess, but it's getting 6. Hard to know what that is. And 6 is not D6. In fact, D6 won't be. It's not like a valid ASCII character. It's because it's got the upper bit set. But yeah, I think that's that. I've made some progress, and I explained through kind of the start of the parsing of the magnet links, and now I'm kind of getting into the problem where I can't actually get the right requests sent out. But that's alright. I hope you enjoyed watching anyway. I just noticed the rain just started bucketing down and I have to get back to the house. But that's alright. That's a huge problem. Thanks anyway for watching. If you enjoy watching these, feel free to let me know in any way you like. There's a bunch more programming videos. There's a few playing game videos. Yeah, it's interesting. Have a look.